Imagine tossing a book into a fire. It burns to ashes, but the information, the words, the ideas, the story can still, in theory, be reconstructed from the smoke and ash particles if we track every single molecule. Now imagine throwing that same book into a black hole. Does the information vanish forever, breaking the fundamental laws of physics? This question has baffled scientists for decades, known famously as the black hole information paradox. At the heart of this mystery is one name: Stephen Hawking. In 1974, Stephen Hawking made a groundbreaking discovery. He realized black holes aren't entirely black. They emit radiation, now known as Hawking radiation. This meant that over immense spans of cosmic time, black holes could evaporate entirely. But this posed a massive contradiction. Quantum mechanics says information can never be destroyed. General relativity, however, seemed to suggest black holes erase information permanently. This fundamental clash birthed the information paradox. How could information simply cease to exist? Hawking himself wrestled with this puzzle, fundamentally shaking our understanding of physics. When physicists talk about information, they're referring to the quantum state of every particle in the universe. Think of information as the unique configuration of atoms in your body or the pattern of stars in a galaxy. According to quantum theory, these configurations, this information, must always be traceable backward and forward in time. Nothing should ever erase it completely. Yet black holes appeared to be the ultimate exception, consuming matter and apparently destroying this vital information. The scientific community was deeply unsettled. Was physics broken? To grasp the paradox, we must first understand Hawking radiation. Near a black hole's event horizon, particle-antiparticle pairs spontaneously form due to quantum fluctuations. Typically, they annihilate each other immediately. But at the edge of a black hole, one particle might fall in, while the other escapes. Over time, the black hole loses mass and evaporates. Here's the crux. The escaping radiation doesn't seem to contain any of the information that fell into the black hole. If the black hole disappears, the information is lost forever. Hawking's realization ignited decades of debate, confusion, and brilliant theories. One revolutionary concept emerged in response: the holographic principle. Imagine our universe like a hologram, encoding all 3D information onto a 2D surface, similar to how a hologram encodes a 3D image on a flat film. Physicists proposed that black holes might encode the information on their event horizon, preserving it rather than destroying it. This theory radically suggested that the true nature of reality might be encoded in lower dimensions than we experience, potentially solving Hawking's paradox and reshaping physics as we know it. Fast forward to today, where the latest breakthrough involves something called entanglement islands. Physicists discovered that information falling into a black hole might be recoverable through quantum entanglement, a spooky connection between particles separated by vast distances. In simple terms, information might leak out of black holes subtly encoded within Hawking radiation itself, thus preserving the laws of quantum mechanics. Recent papers suggest entanglement islands could finally offer a resolution to Hawking's enduring puzzle. Resolving this paradox isn't merely academic. It could unify two of physics' greatest theories: quantum mechanics and general relativity. A solution might pave the way toward a theory of quantum gravity, a unified description of all fundamental forces. It also forces us to reconsider the nature of reality itself. If information is indeed preserved, then black holes aren't destroyers, but rather cosmic storage devices, repositories of universe-scale data. Stephen Hawking left us with questions that still echo through modern physics. Solving the information paradox would not only affirm his legacy, but fundamentally change our understanding of the universe. As we continue to peer into the cosmos, unraveling its mysteries, we're reminded of the profound interconnectedness of all things. the very essence of information that binds our universe together.